In this example, we're going to walk through logistic regression and set you up for your homework this week. So we're going to use this universal bank.csv file and make sure it's in our working directory first. And then we'll go ahead and import the following libraries. We need NumPy, Pandas, and some libraries from sklearn, as well as Matplot for plotting. And then the first thing we're going to do is we're going to load our data in to a data frame. So we'll load it in using read CSV, and then we're going to drop the ID and the zip code columns. These are not going to be important for our predictions, so these we don't want these features in our model. Then we're going to replace the spaces in the column names with underscores, and then I always like to view the data to make sure that it's working correctly. So when we do that, we can see we have this nice data set and it looks fine. We've got all these binary variables here, as well as some other numerical variables. And there's one thing that we need to do with this education column. We want it to be split into categorical dummy variables, since this education column has values corresponding to the associate's degree, bachelor's, master's, etc. So to do that, we use this get dummies command, and we want to drop the first column. The reason we do this is because if we didn't, we would have multicollinearity between those columns. So if you think about a simpler example, if we had a column for male and a column for female, it would become problematic because every single time one is 0, the other is 1, so they're perfectly collinear, and we don't want to introduce that kind of multicollinearity into our model. We'll get a ton of overfitting. So we only need one column, male or female, but not both. So for when you have more than 2 options, it's the same thing. You just drop one of the columns to remove that issue of multicollinearity. So let's go ahead and do that. And then when we run it, we can see here, so there's looks like there were 3 education variables, and it dropped the first, so we have the second and third still in our data set. Let's move on and prepare our model. We're going to split the data into the features that we're going to have in our model and then the target variable, which is going to be personal loan. So we want a model that's going to help determine whether a customer should be accepted or rejected for a personal loan given these other features. When we split the data, then our X data set will have every column but personal loan, and our Y data set will have personal loan. Now we're going to partition our data into training and validation data. So we're going to split X and Y into training and testing, this function you've seen before. And for the argument test size, we're going to do 70-30 split just to see what we get. And then we're going to fit our logistic regression model. So we're going to use the logistic regression, and we'll fit it to our training data set. Let's go ahead and print our intercepts just to see what our model looks like. And then we need to evaluate our model. So there's a couple ways we can do this. We're going to look at our accuracy, precision, recall, and F1 scores. And to do that, we will fit the test data to the model to get our predictions. And then for accuracy and precision, recall, and F1, we're comparing our test to our predicted values. So when we run that, we get pretty good accuracy. Precision's not bad either. And then a recall of 0.67 and an F1 score of 0.77. So we're going to go ahead and apply our model to the entire data frame, and that will help us examine how the different fields are playing against each other, and that will help you narrow your focus for the homework. So how does our model look now? Here's our model fit to the whole data set, and we can add a column called prob, where we take the probability predictions and then write them back into the data set. So the probability that X is going to be yes, basically, is what we are adding to the column. So here we go. Now we have this additional column. And now it's helpful when you're deciding what you want to use for your homework because you're only going to be selecting 3 variables out of all of these, to do some visualization on your model performance. So let's look at a couple things. Let's look at some histograms first. So how did our model do visually? The first is a histogram of those probabilities. So you can see there's a lot of like very low probabilities between 0 and 0.1, and then 0.1 and 0.2, and so on. And our threshold is right here at 0.5. So when we do our classification, everything below 0.5 gets grouped over here into 0 or no personal loan, and over everything where the personal loan is above 0.5, we would accept that customer for, would be over here at 1. Okay, I think it's also helpful to see a confusion matrix. This will show us the amount of true positives, false positives, true negatives, and false negatives. So we can use this confusion matrix function. And when we do that, we get this really nice confusion matrix. So we can see that there were 1,332 instances where the model predicted no, and we actually, the actual value was no. The number of times the model predicted no when the actual value was yes was 52. And then when the number of times the model predicted yes when the customer was actually not accepted was 11. And then the true positive rate, yes to yes, is 105. So these, this confusion matrix, these values are helped used to calculate the accuracy, precision, and recall. Okay, another thing we can do is look at the ROC and AUC curve. This will tell us the true positive rate against the false positive rate, and the AUC score indicates the model's ability to distinguish between the two classes. So when we run this, we get this nice graph here. This is a pretty dang good model. This line here basically represents how accurate the model would be if it were just guessing. And this is how accurate the model actually is. And then we can also see how each feature contributes to the model based on their coefficients. And this in particular might be helpful when you're deciding which features you want to use for your model. So these are how much, according to their coefficients, these features impacted the classification of each input into the model. So that leaves you with your assignment. You're going to choose 3 good features from the model to develop a more refined model with only those 3. Store your new feature set as new X and your new model as new model. And make sure you note which features you're using. Make sure your code is well commented, and break it up into as many chunks as you need to in order for your code to be manageable. And then after you run your model, assess its performance. How did it do with your new feature set compared to the first model? Can you produce a new confusion matrix, a new ROC-AUC curve? And what do they tell you about this model, your new model, compared to that first one? So go ahead and place your code first, and then at the very end, use this markdown cell here to place your responses. And then when you're done, go ahead and export to HTML and submit your homework.